Welcome back to some iOS programming fun. Today there's no pretty slides, so we're just going to have to kind of do an example without pretty slides. As always, you can go to the course website to get information. So what are we going to do today? So we've been kind of coming through the low levels. We did our fraction class, we did properties and protocols. Today what we're going to do is we're going to try to make a practical example of using inheritance. And the practical example that we're going to do is we're going to revisit our tic-tac-toe solution that we've done previously. So we already did this tic-tac-toe thing. We did it back, I don't know, I guess we finished it up day 7. So we're going to go back, we're going to revisit the tic-tac-toe. We're going to use inheritance. We're going to see how inheritance is often used in apps. We're going to fix that up. You should have a functional copy of the tic-tac-toe game. If somehow or another you don't, I was nice to you, and you can click on the starting code if needed, and you can go to a link and you can download the code that you should have made in Lab 1. So I'll just go ahead and download this. And all you really need to do is you can just extract it, and then you can move it to wherever you would like to move it. I don't really feel like moving it, so I'm just going to run it from right here. So if you open this up, this should be the solution to the previous tic-tac-toe game. Depending on what version of the SDK you're using, it might say missing base SDK. If that happens, just click on the project, info, and then under the build, you should be able to select which base SDK you've got. So just select the base SDK that's right for you. So if you run this, we'll go ahead and run it on the iPhone and see what it looked like, and then we'll run it on the iPad and see what it looked like. It wasn't a bad app, right? So it had some good things going. So on the iPhone, it looked pretty good. So the iPhone is really what these images were laid out for. And so you can see everything fits nicely. If you rotate by holding Command and hitting left, you can see that the iPhone chose not to support rotation. It looks a little silly on its side, but this is actually what we want. So it doesn't rotate the screen no matter where you go. If we load it again, though, for the iPad, so on the iPad, Apple strongly recommends that you support rotation on the iPad. So the iPad is the one where the game really isn't quite as good as it could be, right? So on the iPad, you can see a couple of things that we don't really like. First off, the images size are really made for the iPhone, right? So they're not big enough, for one. The new game button, it works, but it's not really the size for the screen. And if you rotate, you can see it doesn't support auto rotation. This is kind of a big no-no for the iPad. The iPad is supposed to support all 4 orientations. They say very clearly, iPad shall support all 4 orientations in numerous places. So that's one of the things we want to fix. We want to support auto rotation on the iPad. We also want to fix up some of these images. To help fix up some of these images, what we've got is we've got some more images for you, so some tic-tac-toe image files. I'm digging these out of the Lab 2 folder, but I'll go ahead and make a link on the calendar page as well, just because it'd be nice to have it there. So go ahead and download these new images. The idea of these new images is that it's going to have all the ones we had before, plus it'll have a couple specific to the iPad. So if you extract this guy, the things that you can see that are in there, it's the old board, the old icon files, then there's a new iPad board, and then there's a new O and a new X. There's also a new button, a new game button. So the ones that we're going to add is we're going to add these 4 iPad images. Another way you can add images, I never choose to do it this way, but you can actually just drag and drop things as well. I always choose the the Alt Option A, but you can also just drag them over, and you can copy them in. So that's another way you can add things to your project, is you can actually just drag and drop with Xcode, which is kind of slick. Alright, so now we've got these 4 new images, and we want to use them for the iPad. So let's get started. So we're going to start making some changes. So the first couple steps will be easy. If we want to use this new board image, we can fix that just in the zip file. So that's fairly easy. We click on the iPad zip file. We had this set up from last time. And you can see that there is a background image, and we're just going to real quick replace it. So if you click on the UI image view, and you change it from board.png to iPad board, you can see it'll use the new board. Likewise, if you click on the button, you can see that it's got an image, and if you change it from wood button to iPad wood button, and then we hit Command equals to make it go to its default size. To be honest, I think this button's still a little too big. Let's make it a little smaller. Just grab a handle and make it smaller. If you hold down Shift, it'll maintain the aspect ratio you want. Cool. So now we've got a new game button. I'll move my message down a little. And so now we're starting to get things set up a little better with our new images. Nothing too exciting. Let's go ahead and run it and see what we've got. Oops, ran it for the wrong device. Let's go back and fix that. So we're just trying to fix up things primarily for the iPad. So you can see that we've got a new game button that's kind of sized for the iPad, but you can see our X's and O's are still too small, right? So that's what we're going to fix next. We're going to fix the X's and the O's. Let's look back and see where that happened. So where that happened was in the View Controller implementation implementation file. I think it's cold in Indiana. And where we picked these files was in the viewDidLoad method. If it's a big file, I'll usually kind of navigate it by using the drop down of the functions. This is where we picked what was X and what was O. So we did it inside viewDidLoad. We saved it to an iVar, and then we used it later. So really what we want to do is for the iPhone, we want to stick with these two. But for the iPad, we want to use the 2 new images. A couple ways you could do that. You could do it right inside this function by looking at what model the device is. But that's not the solution we want to go, because that's not the most robust solution. Really what we would like to do is we'd like to use inheritance. We'd like to have a Tic-Tac-Toe view controller that serves as the superclass, and then a subclass that's specific to the iPhone, and a subclass that's specific to the iPad. So let's go ahead and say add new file in the iPhone section. And what we'll do is we'll create a CocoaTouch class, a UI view controller subclass. We do not want to say targeted for the iPad because we're doing the iPhone one this time. And we do not need a zib because we've already got a zib file because we're retrofitting an existing one. We'll also, in the future, go through one of these from scratch instead of retrofitting an existing one. So this new view controller we're going to make is going to be called Tic-Tac-Toe View Controller _ iPhone. Then we're going to do the same thing for the iPad. We're going to make a, and this one we are going to target for iPad. And this one we're going to say Tic-Tac-Toe View Controller iPad. You can see that the header files are awfully similar, depending on which one you targeted, right? So very similar. However, the implementation files have a couple differences. The main one being the should auto-rotate to interface orientation. If you look at the iPad one, under the should auto-rotate to interface orientation, it says true, meaning it should allow every orientation. Whereas if you look at the iPhones, first it's commented out, but if you were to uncomment it, it would say UI device orientation portrait only. Now it turns out that if you comment it out, or if you don't comment it out, it doesn't matter because it does the same thing either way. The default is portrait only. I'm going to uncomment it just because it's kind of a highlight of this this video. So now you can see that we've got a specific class for the iPad, a specific class for the iPhone. Making a class doesn't really do anything by itself. You have to create instances of the class. So the place where we created the instance of the Tic-Tac-Toe view controller was in the main Windows zip file. So zip files create instances, and you can see that this is where it created the Tic-Tac-Toe view controller. What I want to do though is instead of saying Tic-Tac-Toe view controller, I want to make a Tic-Tac-Toe view controller iPad. So now it's going to make that one. And then also for the iPhone, instead of just making a Tic-Tac-Toe view controller, I want to make a Tic-Tac-Toe view controller iPhone. You can see that the link is still established. It's still connected to the root view controller. Oops, I thought it was still connected to the root view controller. It looks like it whited out. Let's just go ahead and make the connection again. I know what it did. It doesn't know that it can connect to it just yet, and one of the reasons it doesn't know it can connect to it is because it's expecting to see a Tic-Tac-Toe view controller, whereas this one we haven't set it to subclass yet. So let's do that now. That was something I was always planning on doing. Tic-Tac-Toe view controller. So this one is a subclass of the Tic-Tac-Toe view controller. So we say it's a subclass. We also import that header file. We're going to do the same thing in the iPhone's version. It's a subclass. That's interesting. So we'll go fix that connection problem that we were having a second ago. So he is connected to him just fine. And then in the phone, we had deleted this connection, so we'll remake that connection. Cool, and then that warning I didn't quite understand. Let's see, I'll just kind of run it again and see what it says. So it says root view controller of app delegate iPad is connected to Tic-Tac-Toe view controller iPad, but Tic-Tac-Toe view controller is not kind of Tic-Tac-Toe view controller as specified by the outlet type. It is. Maybe it really didn't like my order of operations, because it is now a subclass. Before, when I did this example, I did the order opposite. I changed the subclass first, then I connected it. Let's just assume that it's going to work, and let's assume that the warning is not really a good warning. Cool, so let's start making some changes. So now we've got a subclass. The first thing I want to do is I want to see if my subclass is even running, right? So let's just kind of make sure that our subclass is even running. What I want to do is I just want to put a message in here that says, you know, running subclass iPad. And then inside the iPhone one, I just want to see that it's actually using the subclass. So this one will say running subclass iPhone. So now if I build and run this, when the iPhone launches, if I check my log, I can see it says running subclass iPhone. You can see I had a bunch of debug statements in mind, but the bottom one is the only one you really care about. So running subclass iPhone, so that one's good. So it's actually using that subclass. And then if we switch it over to the iPad and run it, it should say running subclass in the iPad. Cool, so what we've done here is we've got a subclass that's specific to each one, but you can see the app still ran, and that's because they are using all of their superclasses implementation, right? So let's go ahead and start making a couple changes to this. The first change that we want to make is we want to use different images. So you can see that before, in the view did load, we always picked these images. What I'm going to do now is I'm going to cut that out of the superclass because that's going to be specific to each one. And in the iPhone's version, we're going to use these images, so that works out just fine. So I stuck that into the iPhone's view did load. So you can see it calls super. And you can decide, which order you want to call super. In this case, it doesn't matter. So you can put it at the top or the bottom of the subclass. And then inside the iPad one, we're going to do a very similar thing, except for he is going to use the iPad X and the iPad O. So if we were to run it now on the iPad, you can see that it now uses the new images for the X's and the O's, which is kind of neat. You can see that there's a couple things that are not perfect. You can see that mine, I should probably bring them down just a little bit. Let's play a full game out here and not win it. Oh, I can't not win Tic-Tac-Toe. Let's do it this way. Cool, so you can see that there's a couple things that I'd like to fix. First, you can see that this top row is a little high. Then this one's barely high. Then this one's not too bad. So I want to bring down those. So when I switch my images, it's not surprising that my layout changed a little bit. So let's go in and let's just kind of fix up our layout a little. So these three guys, I now want to bring them down some. Cool. And these three, I want to bring them down some as well. Cool. And then these weren't too bad, but I'll bring them down just a scooch. Great. So now that part is fixed up. But now if we run it and we see what auto rotation looks like, so you can see that they're in much better places. So the portrait looks pretty good. If you hold down Command and rotate, though, you can see that auto rotation is allowed, but it does a bunch of wacky stuff. So you can see that the background image didn't do too bad. It squished to go into the landscape mode. Obviously, this is not ideal, right? So squishing is not great. But for today, we're just going to do the bare minimum to support auto rotation and nothing else. However, you can see all the other UI view subclasses, the button, the label, and then these buttons. They didn't do anything at all. What they did is they maintained their distance to the upper left-hand corner. So if you watch it, you can see that they all maintain the same distance to the upper left-hand corner, and this bottom row just completely gets cropped off, right? So we need to change that. The first place that you should look for changing auto rotation is inside the zip file. Inside the zip file, you can change how things behave with auto rotation. And so you can hit Command 3 to bring up their behavior with auto rotation. So you can see the reason that it maintained its connection to the upper left-hand corner is because I had both of these struts connected. What we'd rather do is we'd rather just let it float so that it'll kind of squish with the board, so it'll kind of have the same behavior the board does. So let's just go through each one and let it float with the board. Kind of a tedious process, I know. And so these struts were covered in Chapter 5. So hopefully people already have some familiarity with this from Chapter 5. We're kind of doing in lecture a couple of the things that Chapter 5 did. So if we do that, we can see that it's going to do a little better. So it put them in relatively the right place, so substantially better than last time, right? Because before the bottom row was off the screen. You can see that there's still a few things that are not great. For example, they're too tall. So if we want them to get shorter, one thing we could do, obviously if you do it in code you can do a lot of things, but one thing we can do that's easy is in Interface Builder we can click on this Adjust Vertical. So what this does is if it's in a screen that's tall, so portrait is tall, it'll be one size, but then if it goes to a screen that's shorter, like the landscape, it will change its height accordingly. So if it's in a shorter screen, it'll get shorter. And this is actually the same thing that the board does, so it should get shorter by roughly the same amount, right? So it should look better in terms of actually fitting in the squares. So if we rotate, you can see that now they kind of fit a lot better. Our O's look a little funky when they got squished, but you know what? It's not too bad. It's playable, right? You can click on New Game, and you could choose to play Tic-Tac-Toe like this. The thing that's not acceptable is this label is just sitting right over the board, and actually this button we're going to want to move it to. In Portrait they're vertically aligned, which is great, but in Landscape what we really want is we want them to be horizontally aligned. So let's go figure out how we're going to do that. To do that, we're going to need a connection to each of these so that we can move them around programmatically. We've already got an outlet for the label. The next thing we're going to do is we're going to create an outlet for the button. So we really only need this outlet on the iPad. So we're going to make this outlet into the iPad's subclass. So we're going to say New Game Button. So now we've got a pointer to go to something. And we'll just go ahead and say non-atomic retain IB outlet. So that should be very familiar with things we've done in the past. I could use our new underscore style, but I won't bother. So make an iVar, make a property, then we're going to synthesize it. Since this is a view controller, we've got to set it to nil if the view unloads. So we're trying to be good memory management citizens. And then of course we need to release it within dealloc. So we've got a pointer, which is a good start, but we also need to connect it. So go ahead and click on the Tic-Tac-Toe zip file for the iPad. And so now something slightly different is going to happen. Usually we would just control drag from the file's owner, and it would give us an option. There's no option here. The reason that is that currently it thinks that file's owner is a Tic-Tac-Toe view controller. That didn't cause any problems because it's really a Tic-Tac-Toe view controller iPad, which is a subclass. So that was totally fine before, but now we need that subclass's extra functionality. So instead, let's tell it really what you are is you are a Tic-Tac-Toe view controller iPad. That's who you really are. So now when we connect it, we can see, it's got a New Game button that it can connect for us. So we've got a pointer to it, which gives us, the power to make changes. Having a pointer by itself doesn't do anything until you use the pointer. So what we want to do is we want to, when we rotate, move these things around. So what we want to do is we want to make a new method. I'm going to get rid of these. And so the system, when it rotates, it automatically calls a method on UI view controllers. And so you can look up in the help to figure out what that method is. So if you were to look up UI view controller, there is a method. Oops, I got to log in. There is a method that it gets called automatically when something rotates. Now the trouble with overriding somebody else's class is you have to know what they call things, right? So you have to figure out exactly what they want to call things. So you can see that there's a section that's called responding to view rotation events, which is pretty handy. And the one that we're going to override is this one. So will animate rotation to interface orientation. I think that you could use either will animate or will rotate. I'm not entirely sure what the difference is off the top of my head, but read them, and then you can figure out which one is right. I think the one that we want is will animate, so we're going to override will animate to interface orientation. Override this. We're going to put information in here, and what we're going to do in here, so like our to do, is if it's portrait, put the button and label vertical, and then if it's landscape, we're going to put the button and label horizontal. So what we need to do is we need a way to figure out whether we're portrait or landscape. We also need to figure out where to put them, right? So that's our goal. So let's go ahead and figure out where to put them first. Or now let's go and write the code first. So what we're going to say is we're going to say if the interface orientation, so that's what I got passed in, if that is equal to interface orientation portrait, or if it's equal to UI interface orientation portrait upside down. So if it's portrait, it'll be one of those two. You can see that the way that I magically did this is code completion made my life easier. There are constants for these different interface orientations, and they all start with the same words, UI interface orientation, which was the name of the enumerated type. So all I did is I started typing this, and then I just saw what options it gave me. If you would like, there's also a shorter way to do it. So instead of typing both, people do this so often that they made a little macro for you, and it's called UI device, UI interface orientation is portrait, and it is a macro that you need to pass in the interface orientation that you got passed. If you command double click on this, you can see that all it really does under the hood is it's just a convenience macro, so it's a preprocessor macro, and it just puts in that code that we just typed, right? It's just a little shorter. And then if it's not portrait, it'll be landscape. So inside this, what we're going to do is we're going to set the center point of the message. We're also going to set the center point of the new game button. So what we need to do is we need to figure out where do we need to set the center point to. Dot center is a property of a UI view. And this property of a UI view center point, we can scroll down and find it fairly easy. It's called center. It is a CG point, is the type it is. What a CG point is actually just a struct. It's just a plain old C struct. It has two CG floats in it, an X and a Y. And so this is what we're going to use to make the center. As a convenience, there is a function called CG_point_make, which lets you make a point quickly. So you're just going to pass it in two values, and it'll make the point struct for you. So this is the style that we want to use. The next question is, what are the values for these things? What I do to figure out the values is I open up the zip file, and I move things around, and I just look at the numbers, right? It's kind of a crude way to do it, but you know what? It gets the job done just fine. So if I click on the New Game button, and you can see right now it's showing me the center point, so it's showing me this point right here. I can see that right now its X is at 384, and its Y is at 77. So I'm just go ahead and pasting those in. For when I'm in portrait, this is where the New Game button is at. And then for the message, the user message, it's at 384 as well. So 384 is the exact center of a 786 screen, or 768 screen. So that's all set. That was easy. Now to figure out the other ones, what I'm going to do is this. I've got the view selected, so nothing's highlighted. And if I hit Command 1, I can change its orientation to landscape. And I can just see what it would be like. So this is where I can move these things around. And I can get them all positioned. I'm going to go ahead and make the user message a little shorter. So it should be fine. So I'm going to get these things about where I want them. So now I can say that my New Game button, when it's in landscape, its X is 774. And then its Y is 104. And then for the label, its X is that, and its Y is that. Cool. And then when you're done with it, it doesn't really matter which orientation you leave it in. I'll go ahead and put it like this, and it also doesn't matter where these labels are at, right? So I mean, you could put them wherever you wanted. We're going to be moving them around programmatically. So the only thing it's doing in Interface Builder is it's creating the object and it's connecting it to your pointer, but it doesn't matter where they're at because we're going to change it programmatically. So I'm going to intentionally leave them in nonsensical places just to prove that point. And what happens now when we run it is whenever we change orientation. Oh, I didn't call it in view to load yet. Whenever we change orientation, it'll rotate these to a good spot, right? So if we rotate to this, it'll put them here. If we rotate to this, it'll put them there. And then you can see when mine started, it started off kind of funky. If you wanted to make sure that it starts off in a certain spot, you can actually call this method if you want. So it gets auto-called by the system when a rotate happens. But if you want to make sure that it gets called right off the go, you can send it in a call. And there's this convenient thing where view controllers know their orientation at all times, which is kind of neat. And so you can just say, call will animate, passing in the current one, and that's just to make sure that those labels are up to date. So just make sure it updates it when you get started. Cool. So that is our example for today. Neat. This is officially part of Lab 2, so people that are in the class, make sure that you show this to me to make sure you're following along and got things going. That's it. See you next time.